Hello and welcome back to our OpenComputers tutorial series. My name is Lord Yoda and I'm here with Sangar, the lead developer of OpenComputers, and Daka Total, our cameraman. In this part we will continue to talk about the features of 1.4, and there are still some quite nice things left. So Sangar, what have you in store for us?
So let's finish with the last thing we should maybe have done in the last video, which you also already mentioned, which is the AE integration. So as you may notice, there's an adapter next to the controller of this AE system, and this actually has a point. This makes sense, believe it or not. You can control, oh god, hopefully stuff still works now, yes. Maybe, yes. The ME controller is a component, so you can use this to interact with, well, your ME system. Most importantly, you can use this to start crafting jobs. So, for example, if we go ahead and look at what this component can do, we will see that there's in particular one method which is called getCraftables. This gives us, as the information already tells us, a list of items that can be crafted by the ME system. So let's have a look at this. This is basically, so there's only one recipe registered right now. Maybe we can have a look at that so you get a better idea of what this represents. We have in here one recipe which is for sticks, and we have a few planks in here. So this function returns a list of tables which basically represent the different crafting operations, which you can query for the stack that is crafted using that crafting operation, and then you can call this request method, which will actually start a crafting operation if possible. So if I get the first one, which will be the only one that we have, which is the one for the sticks, and then call request on it. Let's say I want one stick, which of course is less than we have. You see that we also get back another object which you can query for the status of the crafting operation, which obviously now is lost to us because I didn't store it anywhere. But if you need it, you can store this and check if the crafting operation is finished or was cancelled by a user, for example. And if we go over here and look at the inventory of our ME system, we see that now we have 2 sticks, which is, whoops, actually the correct recipe, not 4, because as you may see, we have different stuff in here. Which one is it? This one is it? I guess, no it isn't. Wait, this doesn't make sense. Ah, this one is it. There it is. I had to find the recipe, sorry for the confusion. Right, so this recipe gives us 2 sticks, so not the 4 you may have expected. So this is quite correct. And we can also go ahead and request more than that. So let's say we want 10. So that'll also work, and then it'll process all of these and craft them for us. So now we have 12 sticks, as we might expect. And this works for any number, of course, of recipes in the system, as long as the computer is powerful to get the full list at once and keep it in memory to not run out of memory. So if your ME system is very complex, you may have a problem. So you may want to keep it as subsystems or something like that. But in principle, this is how it works. And there's of course some other methods you might find useful. So the number of crafting CPUs connected, the list of fluids and items in the network, stuff like that. That's the final part regarding integration, and then we can move on to the new major changes, which I sort of mentioned earlier, which is the EEPROMs, so these little bastards here, which basically are one more item you need to start your computer now. Sorry about that, but there is a very good reason I decided to add this little bit of complexity. This now makes stuff a lot more flexible for people that want this, and there are quite a few that do. Before, basically the code that checked for file systems connected to a computer was hard-coded into OC itself. So if you started a computer, a bit of code provided by OC was run, and that checked for file system components and looked for the init.lua file on the file system to try and boot from it. This piece of code is no longer hard-coded in OC itself. Instead, what now happens is that you put an EEPROM into your computer, so you craft it like this, and then you can craft the normal EEPROM together with a book to get the Lua BIOS, which is essentially the piece of code that was previously hard-coded. So this now contains the logic that looks for file systems with an init.lua script on them. The difference here is that there can be only exactly one EEPROM per computer. So the computer can, when starting up, basically just check, is there an EEPROM connected to me, and if yes, get the binary blob of data that is stored on this EEPROM and go from there. So for Lua, that's basically just a short string. These can store up to 4 kilobytes of data as a pure byte array, essentially. So for Lua, this byte array is a string, which is the script that is used to start the computer. We can have a look at this. I think, what was the L? Yes. So this is essentially sort of the code that was previously built into OpenComputers and now gets programmed onto an EEPROM if you craft it with a book. And that's the logic that looks for, that binds the screen to the graphics card if there is one, and then looks for a file system with an init.lua script on it. But you can, of course, write whatever you want onto these EEPROMs. So, for example, what you could do is you can put a little script on there which looks for network cards and then tries to get a bit of code from another computer in the network. So you can boot essentially just via network if you want to. You don't even need a real file system on your computer. Or you can boot from any other kind of device as long as you have a way to reasonably interpret the data on that device. For example, you could boot from Computernics tape drives if you wanted to. Stuff like that. So there's a whole lot more flexibility to this, with the downside that you have to craft one more item to actually get your computer to run. You need this in any kind of computer, so you also need this in the servers, you need this in the robots, you need this in the tablets, and in the 2 new devices which we will be talking about now. So the one new thing which I think I actually forgot to put in the chest is the microcontroller. So this is a new block, this is the microcontroller block, and you build it using one of these 2 tiered cases. So this is again crafted normally using a shaped recipe, and then you put it into the assembler to actually configure and build your microcontroller. So as with any device, you need a CPU, some memory, and then the EEPROM. And the specific difference here is that microcontrollers do not have any kind of file system. They only have their EEPROM. This basically reinforces the fact that these are meant for very specific tasks and a very special purpose. So usually you will want these to just throw in a Redstone card, for example, and configure and run some little script that reacts to Redstone signals and changes its output based on these signals, for example. And, well, there are 2 tiers. The first one is even more basic than the second. And the second now has a tier 2 card, so you can use bundled Redstone if you want to. They do not have access to external components, so they are like robots in that regard. For example, if you have a screen or something, you cannot access that from the microcontroller. It can only use its internal components. So again, these are very, very special purpose and are meant that way. So if you need anything with more power, use a computer.
So, sorry to ask. So all the program logic I want this microcontroller to have has to be on the EEPROM, correct?
Correct, unless of course you have, let's say, a network card in there, so they can still send and receive network messages, and in the T2 you can even have a wireless network card if you want to. And as I mentioned before, if you have, say, some script on your EEPROM which actually queries more code from a remote location, then you can have any kind of code running on there as long as it fits into the RAM, of course, of the thing. But yes, the basic programming of the device has to be on the EEPROM itself, and only the EEPROM. Right, and it has a upgrade slot, so you will have to have a look at what upgrades fit in there. Most do, I think. So, for example, the piston upgrade works and stuff like that. So that's the microcontrollers. I don't think we'll actually have to show these off. These are pretty basic, so just if you need them, use a redstone card and write your code into the EEPROM and have them do their thing. One important thing to note, however, is that you can change the EEPROM installed in a microcontroller by crafting it again with another EEPROM. So if you have an empty microcontroller, you can just craft it together with an EEPROM to insert that EEPROM into the controller. If there's already another EEPROM in the controller, the old one gets ejected and the new one inserted. So if you craft it together with a new one, the old one will be inserted back into your inventory.
How can I change an EEPROM? Is the only place inside the computer, or is
yes,
there
exactly. For now, it's inside the computer. So basically, I did use this little program before, so that's a Flash program. This program can be used to read and write from EEPROMs if you want to do it yourself, so low level. It is a basic component, so if we have a look at this, it basically has a few simple methods like get and set the data stored on it and get and set the label of it. And that way you can change the data that is on it. So for example, if you have your computer and usually you will have your Lua BIOS on it to get it started, you will remove this, put in the other EEPROM that you want to flash and write the data to it and take it back out and put in your Lua BIOS again. So that's how you reprogram your EEPROMs.
Is there a easy way to add code to the default EEPROM? So basically, I don't want to change the basic build-up process, but I want to do something after. So where would I do that?
You will want to. So, well, for most cases where you don't want the default stuff, so for example, for microcontrollers, you won't even want the default BIOS at all, because it's based on file systems which you don't have in microcontrollers. If you want it for a normal computer, you can just save it somewhere. So there's this with the R option. So if you run Flash with the R option, you can save the current BIOS somewhere. Let me just check I have it in there. Yes. So let's see. Let's go to our little subdirectory here where we have some stuff prepared, and then run Flash R old BIOS or something. Then it will write the existing BIOS from the current present EEPROM to that file. So then we can see this is the data stored on this EEPROM right now, and then you can edit it, of course, if you want, and write it back onto the EEPROM.
Okay. And so there is no, I would say, default method where to put in your not default code and leave the rest untouched if I just want to, I don't know, after boot up, send a redstone signal or something.
Well, if you want to do that for normal computers, you just use the init script on your hard drive.
Okay, and on a microcontroller?
Well, on a microcontroller, you just have to write the very thing from scratch, because you don't have any of the stuff available in the file systems, because you don't have file systems, so you have to go from there. There's a page on the wiki, we can put that in the description, which basically lists all the methods and stuff that is available at the very low level. Excuse me, which is previously was mostly there as information for people writing custom OSs. So this is what you have when you work inside an EEPROM. So it's a very limited list. You don't have most of the comfort stuff that's in OpenOS, so you don't have, let's say, the package system, you don't have anything like that. You don't only have very basic features of Lua, like coroutines and these things. There is a little example which we will show in a bit, but I can show it right now. So this file called bios.lua, if we have a look at that, that's basically a very simple BIOS that could run on a microcontroller too. So this assumes there's a modem present, so a network card, and it just listens for packets arriving through the network, expecting them to be some kind of command, evaluating that command, and then sending the result of the command back to the network. So we will use that in a bit, but that's an example for a very low-level BIOS that could run on any microcontroller.
Okay.
Right.
And
okay.
To use the microcontroller, can I place it or?
Yes, it's a block, exactly. So if well, let's build one real quick. After all, I think I have some stuff in here. No, not you. Let's grab a redstone card. So much redstone stuff. Card there. Just for demonstration purposes. Right, I don't have a BIOS right now, that doesn't matter. But if I build it, I get this microcontroller block, and then I can place this somewhere in the world. And right, by right-clicking, you start it. Well, would start it. It doesn't have an EEPROM right now, so it just arrows. You can see, whoops, where it failed by using the analyzer as usual. So it will tell you it doesn't have a BIOS. So please install a configured EEPROM. And they don't have an inventory, they just are simple blocks that you can start by right-clicking and stop by right-clicking again if they're running. Yeah. So that's that. So basically very, very limited and basic computers that use less power, and you can just place and forget, basically.
And I guess are also very cheap.
Comparatively, yes. Right, so that's the microcontrollers. A little more interesting are the drones. So these are kind of like the microcontrollers are to computers, except for robots. So these are mobile computers and are entity-based. So they have a few different options of interacting with the worlds, as opposed to robots, which are, in their implementation, are blocks. So, for example, this new upgrade, the leash upgrade, they can use this to leash entities, which would be impossible for normal robots. So let's build a drone real quick. So of drones, there are also two tiers.
Predator
again,
and normal.
Yeah, I'm not that creative with names. So it's just tier 1 and 2. As usual, you craft these cases with a normal shape recipe, and then you put them in the assembler to configure your actual drone. As you notice, these use endstone, which is basically what justifies them floating around. I would have loved to use these for robots too, but I wanted them to be available before going to the end, so there's that. Let's use this, let's use this. Drones also can have an inventory. So if you install an inventory upgrade, you can use these to pick up items and carry them around. They can also use tank upgrades. We can also use those to carry fluids around. And I think that's all we need. A wireless card, yes, okay. And they look like this. So now all I need is a BIOS, which I will... Wait, didn't I have... EEPROM, there we go. Back and forth, back and forth. So let's put this in here. So this is the EEPROM that I want to flash. And I showed it before, this is the BIOS I want to put onto that. So I run flash BIOS lua. The EEPROM I want to flash is inside, so yes. Wait a bit, and let's call this RC for remote control, and then we're done. And we can pick this up. So this is our RC BIOS now. Let's put the old one back in. And now if we had a crafting table anywhere, there we go. Same as with microcontrollers, you can craft these together with any EEPROM to change the EEPROM installed on the drone. So there's none in there yet. If I hold shift, I see the components installed in it. But if I craft it with it now, I have the RC BIOS in my drone. So now if I go ahead and place it somewhere, let's say over here, and start it up. So if I right click it, the inventory opens. I see it has an internal energy buffer, much like robots do, a little smaller, but they also use a little less energy. And you see it has 4 inventory slots. So unlike for robots, where one inventory upgrade provides 16 slots, one upgrade provides 4 slots in drones. They're just a little more compact in every manner. You'll also notice this little screen-like area to the left here. This is a small area of text. It's nothing like the actual screens. It's just a small, I think, 10 by 2 area of text you can use to output status information if you want to. So if I power it on now, you'll see it starts hovering inside the block where I placed it. If it runs out of power, it'll just slowly fall down to the ground again. If you want to pick it back up again, you will have to shift right click it, which will turn it back into an item, and then you can pick it up. So let's put it down again, start it again, and there it is. And now I have a tablet prepared, which has the other part of the BIOS basically, which is the client program. So let's have a quick look. This basically just is used to send the commands to the drone and read the responses and print them out. So let's start this.
Is this program available in the game, or did you add it?
It's custom, so we can add a link to that under the video too. It's also linked under the Christmas video, where I also demoed this before. Right, so let's say, so the drone has a few basic movement commands. Unlike robots, drones do not have a concept of orientation, so there's no front per se. So whenever you need to provide a direction, you will want to provide the absolute world direction, like north, east, south, west. For which you will have to know the actual index of said direction, because, as mentioned, they only have a BIOS, and this does not include the OpenOS, of course, which is where the site's API is defined. So this is a bit more limited. So the basic movement for drones works by providing a vector to which to move relative to the current target location of the drone. So basically, drones will sit at a specified target location, which will be initialized to the center of the block they were started in. And if they somehow get moved to the side, so if I hit it a bit to move it, it'll try to move back where it came from. And so if I now change the target location, like tell it to go up by 5 blocks, for example, it'll move there. And if I tell it to go down 3 blocks again, it'll go down. And these are also in global coordinates. So positive Z is south, I think. I can never remember. Well, you'll figure it out. So that's about the movement. There are some more methods, like I think, what was it? The velocity, I think, which is basically, maybe it's, oh no, get velocity, of course. The current speed of the drone, so if it were moving up, this would not be 0. So this is useful for figuring out if, well, how fast you're traveling basically currently. And there's also a get offset, if I'm not mistaken. Yes, which tells you how far away it is from its current target. So you can use this to figure out if it has reached its destination. Because unlike robots, the move method does not block. So when you tell a robot to move forward, the robot will be responsive until it finished its move, essentially. For drones, that's not true. You can continue doing stuff while you move from one position to another. So this can be used to figure out if you're there yet, essentially. Other than that, it behaves similar to anything else, except that you don't have, as mentioned, the component, the package library, so you can't do anything like a component dot something other dot method. You'll actually have to acquire these via the low-level methods made available to you. So for example, if I want the leash upgrade, I have to get the proxy for the first component called leash in the list of components, like this. So now I have assigned this variable to a proxy wrapping the leash component. This is how we will have to do it at the lowest level, if you want. So for example, now I can print out the address or stuff like that. So now I have access to my leash component. What I can do now is close this door and grab this spawn egg and throw in a few sheep. Oops, and keep the door closed. And probably, let's see, maybe it works. So now I have to provide a site for this method, which is 0 for down. So 0 is down, 1 is up, 2 is north, I think, 3 is south, 4 is west, and 5 is east, or something like that. So the basic directions. You can also look this up using the sites API on any other computer where it's available if you want to. So let's see, this worked. So now I have this sheep leashed to this drone. Let's see if there's another one in reach. Apparently not. Let's throw in some more sheeps in there. Get going. So it can, yes, it can leash multiple entities at once. I think up to 8 is the current limit. And then you can use the drone to drag them around. So for example, if I tell it now to move, let's say 10 up, it'll actually drag the sheep up. And there's a little, go away, there's a little, well, bug in vanilla actually. So if I go down, even if I would go down slowly, if they now touch the ground, they will die of falling damage. So keep, oh, this one doesn't. Maybe it doesn't. I don't know. To be sure that they survive, you may want to have some kind of, yeah, it does die. Some kind of, either make sure the drone flies low, so they're just dragged above the ground, or have some kind of fall damage reduction, like a water pond or something, where you drop them off.
Or you want to kill them, then you
don't. Or you want to kill them. That's of course always fun too. So, whoops, let's see, can I get another one? Nope. Because that's the final one I want to show. That's the second method basically on the leash upgrade, which is the unleash method. So you can just cut the rope basically. So you can do that too. This will cut the rope for all attached entities, so not just the last one or anything. It will disconnect all of them. So yeah, so basically drones are faster, a little bit more flexible robots movement-wise, more power efficient, but they lack a few features, at least for now, that robots have, such as they can't break blocks, they can't place blocks, and stuff like that. But they can interact with inventories, they can pick up items from the world, they can drop items in the world, they can suck fluids from tanks and put them back in and from the world, and so on and so forth. So all of that works. The main thing they lack is the availability of a tool slot, so they cannot use tools and they cannot break and place blocks. So that's about it. So yeah, that's drones.
Yeah, I think they're very nice.
Aren't they? So I mentioned the status text. Let's just use this real quick. So let's set this to something or other. Field. No, not status test. Status text. Always make that typo. So now you can see this is the text now. So you can set this to whatever you want, as long as it fits. So if you want to use 2 lines, you basically just call it with a new line in there, and then you have 2 lines of text.
Can you color the drones?
You can. You can call, what was it, set light color, I believe, and then you can have, for example, red lights.
Oh, that looks way better.
Oh, that's a matter of taste. or blue lights. Which, by the way, with the latest version also, fence, where's the fence? There's the fence. Also works for robots. Do I have this one here anywhere? Yes. So you can also use a new method since the 1.43 version, I believe. So it also has the set light color method, which you can use to set the color of the power indicator light. So you can use whatever color you want there too. It's just any kind of RGB color you want. And that pretty much covers it, I think. At least on the surface.
Yeah, but I think you will have new features soon.
Possibly. No spoilers.
Spoilers. So, that's it then for this time. Thank you very much for watching. And as always, if you experience any problems, please go to the forums as these, or the IRC, as these are the best place to get qualified feedback. And if you report any bugs, please report them on the GitHub.
Exactly.
Okay, so
right.
You have anything else to say?
Oh, nope. Have fun programming stuff.
Yeah.
Do great things.
Yeah, and show us.
Yes, please do. I'm always happy to see what people do with the mod. In particular with drones. I'm looking forward to that. Right, so thanks for watching.
And until next time.
See you.
See you.